I'll start with a little background. Fish movement studies in Iowa have identified critical habitats for some fish species and revealed the importance of seasonal movements of fishes between these habitats. I'd love to show you some of the results of this, but that's the 50-minute talk. So for today, you'll have to take my word for it. Results of these studies suggest that the modification or removal of barriers to fish passage has the potential to improve fish populations in Iowa's rivers. And recent interest by dam owners in reducing liability for accidents and repairs of aging low-head dams provides us an opportunity to quantify the effects of dam modification and removal on river fish communities. And the presentation I'm going to give today is part of a larger study that we're doing on the response of fish and habitat to stream rehabilitation practices in Iowa's interior rivers and streams. And the goal of this study is to develop management guidelines for the use of stream rehabilitation practices to improve river and stream habitat and fishing opportunities for Iowa anglers. We currently are evaluating 3 different projects. The first one, which I'm going to talk about today, is the conversion of the Vernon Springs Dam on the Turkey River to a rock arch rapids. The 2 other projects are the complete removal of the Rockford Dam on the Shell Rock River, and we have a poster on the other side of this wall on that if you haven't had a chance to look at it yet. And then the partial removal of the Manchester Dam on the Maquoketa River with whitewater and habitat improvements. The Vernon Springs Dam is located in the upper watershed of the Turkey River. It's 250 feet long and 8 feet high, and it's a barrier to upstream fish passage on the river. Although the impoundment above the dam is fairly small at 35 acres, it supports a considerable amount of recreation in the form of boating and fishing. There's also a county park and a golf course and several houses located around the impoundment. So there wasn't a lot of interest locally in doing a modification to the dam that would result in losing this impoundment. The dam was owned by the Howard County Conservation Board, and their goal was to eliminate recirculating currents that contributed to past drownings while maintaining the water elevation for a popular lake. And they decided that the conversion of the dam to a rock arch rapids was the best way to accomplish their goals. And the expected fisheries benefit of the project was the reestablishment of fish passage between the Turkey River downstream of the dam and the upper watershed and impoundment. There were several partners that shared in the $313,000 price tag of the project. They include the Iowa DNR Dam Mitigation Program, the U.S. Fish and Wildlife Service Fish Passage Program, Iowa DNR Fish Habitat Grant Program, Cresco Union Bank and Trust, Cresco Union Bank, Cresco Bank and Trust, and the National Fish and Wildlife Foundation. The Luther Adlin from Minnesota provided the concept, design, and initial construction supervision of the project. Our Iowa DNR Rivers team and DNR Engineering were responsible for the final design and construction details, and Brenning Rock Products was the contractor on the project. Construction began the 2nd week of July in 2010. And the project was completed August 10th of 2010. And this is what it looked like shortly after construction. And this is what it looked like 4 years later, this last August. The goals of our fisheries evaluation of the project were to document upstream fish movement over the structure, and to quantify changes in the Turkey River fish community upstream of the structure. We had 5 fish community sampling sites on the Turkey River. It included 2 sites downstream of the dam and 3 sites upstream of the dam. Site 1 was located 4 miles downstream of the dam. Site 2 was located immediately below the project area. Site 3 was located 2 miles upstream of the dam. And sites 4 and 5 were located on tributaries about 7.5 miles upstream of the dam. The drainage areas for sites 1 through 3 ranged from 75 to 87 square miles. Site 4 was 25 square miles, and Site 5 was 35 square miles. And the distance sampled at each site was approximately 40 times the mean stream width of the site during normal summer low flow conditions. We also sampled 3 control sites on the, 3 sites on the Volga River that served as control sites for our 3 upstream sites on the Turkey River upstream of the dam. The Volga River is a tributary of the Turkey River, and there's no barriers to fish movement between these sites on the Volga River and the Mississippi River. And the drainage areas of these sites, we selected these sites to be similar drainage areas to our upstream sites on the Turkey River. And sampling these control sites gives us an idea of what fish species you'd expect to be present in similar sized sites in the Turkey River drainage where you don't have a barrier to fish movement. And it also allows us to look at variation over time at these sites and compare that to our sites that were impacted by the project on the Turkey River. Our fish community sampling at sites 1, 2, and 3 on the Turkey River were conducted using boat electrofishing. And at sites 4 and 5, we sampled the fish community with tow barge electrofishing. We also used tow barge electrofishing for our control sites on the Volga River. And all of our sites were sampled during normal summer low flow conditions in late July and August. We also marked fish downstream of the dam in 2008, 2009, and 2010. Most fish were marked with pelvic fin clips. But walleyes and centrarchid were marked by removing the 3rd and 4th dorsal spine. We did pre-project sampling on the sites 1, 2, and 3 on the Turkey River in 2008, and at sites 4 and 5 in 2009, and then we resampled all sites in 2010. Post-project sampling, we did at sites 4 and 5 in 2011, and at all sites on the Turkey River in 2013 and 2014. Our control sites on the Volga River were sampled in 2010, 2011, 2013, and 2014. We marked over 3,900 fish downstream of the Vernon Springs Dam, and they represented 21 species. The bulk of the fish that we marked were sucker species, but we also marked a considerable number of game fish such as rock bass, walleye, and smallmouth bass. To date, we have recaptured 31 marked fish upstream of the structure. They include 16 black red horse, 11 golden red horse, 3 walleye, and 1 northern hogsucker. And all but one of these fish were sampled or recaptured in a 2-mile stretch between the dam and the upper end of Site 3. The other fish, it was black red horse, and it was recaptured at Site 5, 7.5 miles upstream of the structure. Our post-project fish community sample showed samples showed a reduction in number of species sampled downstream of the dam. We consistently sampled more species at Site 5 upstream of the dam during post-project sampling. And we saw a slight increase in number of species at Site 4 in the last couple years. But our control sites on the Volga have basically been fairly stable with numbers of species that we've sampled in our fish community samples. We were able to calculate index of biotic integrity scores for sites 4 and 5 on the Turkey River and for our control sites using the Iowa Fish IBI for wadable streams. Our IBI scores have been consistently higher at Site 5 on the Turkey River during post-project sampling. We've seen a slight increase in the last couple years in IBI scores at Site 4, but we've also seen increases in IBI scores at our 2 upstream control sites on the Volga River. Looking at some individual species, post-project sampling, we found 2 species upstream of the dam that were not present during pre-project sampling. These are large-scale stone roller and banded darter, and both of these species are considered species of greatest conservation need in the Iowa Wildlife Action Plan. Large-scale stone rollers were sampled in all but 2 of our samples at our control sites on the Volga River. They were found at both of our downstream sites on the Turkey River during pre-project sampling, but at none of our upstream sites. Post-project, we've seen increasing numbers each year in large-scale stone rollers at Site 5, and we've picked up large-scale stone rollers 1 year each at our upstream sites 3 and 4. Banded darters were sampled in all of our control samples on the Volga River. They were found in all of our pre-project samples on the Turkey River downstream of the dam, but none of our samples upstream. And during post-project sampling, we've seen banded darters in all of our samples at Site 5. And our post-project sampling, we've also, we have 4 additional species that we've sampled at Site 4 or 5, the upstream sites, that were not found during pre-project sampling. And these are black red horse, which is it's listed as a threatened species in Iowa, smallmouth bass, quillback carpsucker, and largemouth bass. Black red horse have been found in all but 1 of our samples at our control sites. They were abundant in our downstream sites during pre-project sampling. We found them in lower numbers at Site 3 upstream of the dam, but didn't find any at Sites 4 or 5 pre-project. Post-project, we've seen an increase in black red horse at Site 3, and we've sampled them at the upstream Site 5 in all of our post-project samples, and at 2 of the 3 post-project samples at Site 4. Smallmouth bass have been found in all of our control samples. They've been found they were found pre-project at both downstream sites and at Site 3 upstream of the dam, but not at Site 4 and 5. Post-project sampling, they've been found in all samples at Site 5 and at 1 of our samples at Site 4. Quillback carpsucker, they were found in all of our samples at our downstream control site. but only one sample each at our upstream sites. We found them in all of our samples downstream of the dam pre-project, and in one sample upstream of the dam. Post-project, we've only found them in one sample each at our upstream sites 4 and 5, and that's similar to what we saw at our control site. So this species is probably just occasionally found in the smaller size stream, like our upstream sites on the Turkey River. So our preliminary results indicate that rock arch rapids structure that was built at the Vernon Springs Dam is providing upstream fish passage for several fish species. It also appears that the structure allowed recolonization of upstream sites by large-scale stone rollers and banded darters. And the rock arch rapids also improved, appears to have improved the black red horse and smallmouth bass populations at our upstream sites, particularly Site 5 upstream of the structure. We plan to continue monitoring these sites to help determine the long-term impacts of the project on the fish community in the Turkey River. And I'd like to give a special thanks to the Decorah Fish Management Team and the Howard County Conservation Board for their assistance in this project. And I can take any questions at this time.
Questions?
Do you think these fish are using the rock arch rapids during off-flow conditions? Are they during certain higher rides when it's moving through and out of the area and upstream? Or are they staying and able to move freely upstream and downstream?
Since we always sampled during, once a year during the normal summer low flow conditions, we were looking more at, whether, from our past studies, that's a pretty stable time of year, so it gives you an idea of, resident fish populations. So we don't really know when these fish moved up over the, what time of year. I would, just from the design of the rock arch rapids, fish should be able to get over it under most conditions. The exception, we had drought conditions in 2012, and there was probably a period during the drought where they couldn't get over the structure. But it is designed, they actually removed about 6 inches in the middle of the dam to encourage more flow to the middle of the structure so that during low flows, and it's designed to be slightly lower in the middle than on the side, so to help concentrate the low flows and allow fish to move up over there during a variety of water levels.
Anyone else?
Mike Hollardale. Greg, I know you've looked at a lot of these structures in Iowa, both the whitewater parks and just the rock arch rapids. I remember a number of years ago seeing a presentation by Chris Bunt from Biotactic, and he was talking about the efficacy of fish ladders. And the way that he looked at it was he had a pool of fish that actually came within a certain radius of the entrance to the fish ladder. And then he had, of that pool, the percentage that actually entered the ladder. And then of that percentage that was in the ladder, the number that actually went through and upstream into the upper impoundment. And so I'm just curious if there's any information that you guys have gained, either anecdotally or through your sampling, that would break things up that way, that would start maybe helping the design of these things pinpoint how you design these things to be optimal for fish species passage. Because I agree they're using it, but it seems like maybe we could do something to provide a little better use of those types of structures.
Yeah, that's something we haven't looked at this point. Our studies have been more looking at changes in the fish populations over time, and with the marking. There's definitely opportunities to do that. Once one of these structures is in place, you could mark fish down below there. There's different techniques you could use, like pit tags and some other like passive integrated transponder tags, and that would allow, you could set up arrays and allow you to look at timing of when fish move up over these structures. It's not something that we've done at this point.
Okay, anyone else? All right, thank you, Greg.
Yep.